دكتور أنا عندي سؤال.
تفضل.
هلا البروت فورس الجوريثم هل لازم إنه التايم كومبلكسيتي تبعها دائما يكون n في m؟ لأن يعني هي الفكرة ممكن تطبق على أكثر من مشكلة، فهل لازم إنه التايم كومبلكسيتي تبعها تكون n في m؟
شوفي دائما خذي قاعده، دائما البيج اوف او يعني البيج او مش لازم تكون زي بعض في كل الحالات، تمام؟ ولكن في اشياء احيانا تكون عامه، يعني نحن نقول اتفقنا في اشياء تكون عامه جدا، يعني اذا انا حيكون عندي مثلا لوب الطبيعي ان، لكن هل فعلا هو حيمشي اذا انا ابحث عن شيء مثلا الطبيعي ان، لانه انا ابحث the worst case انه I will find the element at the end، تمام؟ فلازم امشي على كل الاليمنتس، هذا the worst case. الان في حالات زي ما قلنا الان سيرشنج، انت لما تعملي سيرش مثلا في الباينري سيرش هل يعمل زيه زي السيكونشال سيرش؟ طبعا لا، هناك حيكون لوج ان، بينما في السيرش العادي حيكون اللي هو الان، فبالتالي مش شرط، لا ما هو شرط، يعني ما ناخذها نحن باي ديفولت كده انه اي فور لوب خلاص حياخذ هذا، مش شرط لا. فبالتالي انت شوفي حسب الحاله اللي انت ماشي عليها، احيانا انت مثلا يتطلب البحث تقولي I'll make it faster، مثلا هعمل سورت في الاول، اذا السورت حياخذ بيج او والسيرش حياخذ برضه بيج او، حيجمعيهم مع بعض الاثنين. فعلى حسب الحاله، على حسب الحاله. لو ترجع تشوفي الالجوريثم بعضهم حتلاقيه بالطريقه هذه انه يعمل حساب الاثنين.
أيوة فهمت، شكرا.
اي سؤال، اي استفسار اخر تحبون جنرال يعني في الكورس في غير الكورس؟ طيب الكويزز اعتقد خلصتوا ولا لسه باقي لكم كويز؟ دان؟ انا اللي ماني بي سي سي فوالله ماني متابع نهائيا الموضوع الكويزز عندكم، يعني خلصتوا الخمسه كويزات خلاص؟ باقي واحد، طيب لسه يعني الخميس يمكن. طيب على كل حال نحن اليوم يفترض ان شاء الله we'll talk about our last tutorial اللي هي lecture 11، تمام؟ نحن we talk about 11 meetings او 11 lectures او 11 tutorials. After that we will see what we can do. أنا بالنسبة لي I will attend if you have any questions regarding يعني anything during the course، ما عندي أي مشكلة، حياكم الله. If you think that إنه خلاص it's enough براحتكم انتوا، أنا موجود عموما، أوكي؟ من حقكم يعني. أوكي. أرسلت لكم لينكس، شفتوها ولا ما شفتوها؟ اللينكس في أحد شاف اللينكس وصلته؟ ممتاز الحمد لله. طيب إذا كان في مشكلة وأخشى أن تكون في مشكلة، لكن جربوها إذا اشتغلت يبقى وي ار لكي. طيب بسم الله الرحمن الرحيم والصلاة والسلام على سيدنا محمد أشرف المرسلين وعلى آله وصحبه أجمعين. Lecture 11. Lecture 11. It's يعني I'm not saying far away from course contents. No, it's still يعني within. لكن أنا أتكلم as an algorithms, as analysis of algorithms. No. Today we talk about propositional logic and predicate logic, Turing machine, and computability and limits of computation. طبعا Turing machine very important topic, but in this lecture and in this course we'll just take the idea of Turing machine. But مثلا in the master degree you might take it as a course. Turing machine تمام, you might take it as a course. على كل حال propositional logic and predicate هنا it's just the idea, لكن in مثلا math course you might take the whole course talking about the propositional logic and predicate logic. So let's go. Okay, when I talk about logic, what does it mean logic? Generally, logic. General logic. In general, logic. What does it mean? Logic.
Solving problems in.
صحيح. When you solve a problem, sometimes you will reach to some points that need sort of logic. تمام. One
yes.
of the logics we have مثلا لاحظ هنا معايا propositional logic syntax. We have مثلا or, and. So when we study that in mathematics, you think that it's mathematics only. But now when we studied that in programming language, we found that in if condition you might use مثلا or. So if x greater than 90 or equal 90 or less than or equal 100. And نفس الفكرة. So you can also make it in the if condition. So if I just replace the or by and, so now which one, for example, أنا أقول is more accurate? Is it if grade greater than or equal 90? Or grade less than or equal 100? Now, which one is accurate, more accurate? Is it and or? Generally, if I'm trying to find the marks between 90 and 100.
And, I think.
And or? Is it and or?
Both works, but I think and is more specific.
More specific. Okay, now let's see. If someone got 80, so you will check now. 80 greater than or equal 90? No, false. So that is false. And 80 less than or equal 100, that is true. So we have false and true, which is at the end it will be false. False. Now someone في الشات يقول oh. So now I'm looking for the grade, so I will give the student A. So now 80 greater than 90, that is true. عفوا, that is false. Sorry, that is false. 80 less than 100, that is true. So false and true based on the propositional logic is false. So no, I will not give the student who got 80 A. Now let's try or. If you think that, or some of you think that it's correct. Now 80 greater than or equal 90. The answer is false. It is not. So that is false. 80 less than or equal 100. That is true. So false or true. We get true. So those ones who will get 80 will get A based on that one. So because it is true, so award the student. Now, طبعا depends on the next if, else if. But or here is not working. It's not accurate. Because it will include even the student got 0. 0. Is it less than 100? Yes, it is less than or equal 100. So true. In the or, any one got true, the answer is true. The only case that you get if that both of them are true. Agree with me or not? Do you agree? So that is the idea now, that we need to understand the general idea of the propositional logic. And I believe you took it in some other courses. So logic has profound impact on computer science. Some examples: propositional logic, the foundation of computers and circuit. Database query language. We talked last meeting about the query. When you select something, so is it included? Is it true? Is it whatsoever? In all programming languages, not just Prolog. طبعا example يعني, but I know that, but all programming languages. Design, validation, and verification, such as the password, is it correct or not correct? So you need also sort of comparison here. Inference systems for AI, artificial intelligence, and so on. So that is now في propositional logic. We need the or, the not, the and, the implication, and the if and only if. هذه if then وهذه if and only if. طبعا it's repeating now, or all of them will be true unless both are false. So that is false, and I'm pretty sure that you know it long time ago. And of them false unless both of them are true. Like my case, when I said greater than or equal 90 true, less than or equal 90 true. So since the operation here is and, so that is true, you will get A. Negation, just the opposite. True will be false, false will be true. If then, we'll have all of them true unless the first one, which is the F, is true and then false. Other than that, it will be true. So the only case you have false if condition is true and then will be false. Yet second one, yeah. Second one, okay. If A, then B. That's what I mean. If A, then B. So if these are now, one of them is true, one was second one. Be careful here. The second one. Okay. So we have the other case, which is false true. That's okay. That is okay. Last one, if and only if. If and only if, you will discover here that true will be true. Okay, false, false. So if both of them, if and only if, okay, both of them are the same values, true, false, false, will be true. Other than that, it will be false, 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 false. Then we have some common outputs, like if all of them are true, then that is named tautologies. If all of them false, then that contradictions. Then if they are mixed, generally, okay, they are mixed, then it is contingency. So, maybe some of you remember when we sometimes try to compare between two statements. Are they equivalent? Are they equivalent or not? So if so, then you will say, yeah, they are equivalent, they are not equivalent. طبعا depends on the case. أخذناها أعتقد في بعض المواد الأخرى. اللي هي هذه. Okay. So two statements X and Y are logically equivalent if any of the following conditions have been. طبعا هنا واضح هنا very clear if they are the same, all of them. So we can say yes, they are identical, or they are the same, or they are equivalent if they are having the same one. Yeah, for example here A and B true. So if it is A or B true, not A or B, it will be the opposite, which is false. Not A, false. Not B, false. So not A and not B, that will be false. So are they the same for both? If yes, so they are equivalent. In another word, sometimes you can rewrite the statement. If you have a statement, then you can rewrite it in another way, so it will be the same. It will be the same. So example here, prove not A or B and not A and not B. Are they equivalent or not? So you will take that one alone, you will take that one alone, and you will look at the results. You will look at the results. طبعا very clear هنا إنه results are the same. False, 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 true. False, 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 true. I think you took that one in M131. To prove that two statements are equivalent or not.
Yes, true.
131 now, yeah, 131. So هذا نحن will not spend a lot of time here, but the idea إن شاء الله إنها هي. ممتاز. Okay, then we have some other types like inverse, converse, and contrapositive. Did you take that one also? في M131 أنا ما عمري درست M131 ما عمري درست رياضيات. Did you take that one there?
Yes.
طب ليش جيتوا اليوم؟ كان لو ادري كان اقول لكم go back to M131. Okay. ممتاز ممتاز. هي basically الايديا هنا sometimes if you need to prove something. يعني let's take one example هنا or two examples maximum. When we talk about inverse, the inverse of conditional statement is the negation of both the hypothesis and conclusions. بمعنى if the statement as follows: if B then Q. So the inverse will be if not B then not Q. Example: if you do your homework, you will not be punished. If you do your homework, you will not be punished. Now, inverse basically if you do not. Here is if you do, هناك you do not do your homework, you will be punished. That is logically true, since here is if you do, you will not. Here it will be if you do not, you will be. That's the idea of the inverse. Converse نفس الفكرة. Converse ببساطة if B then Q. The converse will be if Q then B. معكوسة لو تلاحظوا. If B then Q. In the converse it will be if Q and B. Contra positive نفس الفكرة. أعتقد ترى examples not يعني accurate. Okay. بس الايديا أعتقد إنها very clear لكم. So if B اللي هي هنا if you do your homework, then Q, which is you will be punished. Now, if you will do the converse, it will be as follows: if Q then B. If Q then B اللي هي زي كده. The converse will be B if B then Q is if Q then B. Last one اللي هي contra positive. Basically, if B then Q, still in the same example. So the contra will be if not Q, then not B. So you need to be careful. If there is a negation already in one of them, it will be the opposite. So if one of them is if not Q مثلا, then it will be if Q. It will be if Q. هذه ببساطة اللي هي three types of. Then that is purely mathematics here. Predict logic. هنا we talked about propositional logic الأول اللي بدينا فيه propositional logic. تمام. هنا يتكلم عن predicate. So what is the predicate? Predicate is an expression of one or more variables defined on some specific domain. مثلا, for example, I have numbers generally, that is numbers from 2, negatives, positives, zeros, fractions, all of that numbers. Now, integers. So integers also a number, but it has مثلا special case that fractions not accepted في integers. So one is part of the numbers domain, but with specific characteristics. Okay, that is the idea of the predict. طبعا some examples it talks إنه let E X and Y denote X equal Y. So that could be the case. هنا يمكن more clear the last one. Let M X and Y. So we have a domain هنا. So what is the relation now? The relation is X is married to Y. So now, once you represent that by values, it means that that one married to that one. So they are within a domain. Within a domain, we have something called well-formed formula. Well-formed formula, WFF, is a predicate holding any of the following. All propositional constants are propositional variables are WFFs. If X is a variable and Y is WFF, so that sign, what does it mean? That sign. رياضيا mathematically في الرياضيات اللي هي A مقلوبة كده inverted A for all. وهاو about اللي هي الإي
exists but not all.
not all. Excellent. Okay. So truth value and false values are also WFX. So what is meant here? That valid. Okay. Well-formed formulas that it is valid and it's actually okay reach or apply rules. So if I say مثلا integers numbers, okay, part of the numbers generally. Part of the numbers. So now, since all of that apply, yes, that is true. So I can go on more details. If it is integer numbers, then it should not contain, مثلا, any fractions. If it is applied, that is a well-formed, and so on. Okay, and so on. Generally, we have two main quantifiers. The variable of predicates is quantified by quantifiers. There are two types of quantifier predicate logic, which is the universal. Universal quantifier states that statements within its scope are true for every value. For every value. So, an integer number now, if I put it in a domain of all numbers, okay, can we say all the numbers are integer? Of course not. So it is only part of the numbers in general. So, but if we have values, it means yes, all of them, then we can use that one, which is for every value x of x, b of x is true. What does it mean here? Okay, for all what you said, x or for every x, b of x. So is read for every value of x, any value of x that will be true. اللي هي relation like that one. Let mxy denote x is married مثلا. إنه الvalue they must be equal. If they are not equal, it's not part of that one. Example هنا, man is mortal. Can be transformed into propositional form for each x. It means each man. Okay, b of x. So where px is the predicate which denote x is mortal, and the universal discourse is all men. So all men are mortal. Now, if we have 1 or 2 or 10 or whatsoever, not, so that means doesn't work. So we have to go to the next. What is the next? Existential quantifier. وأحد الأخوان قبل شوية ذكر exist. So exist basically is read for some values, not all the values, not each value. So some of them yes, some of them no. Example here, if we say some people are dishonest, can be transferred to as long as now not everyone, no, it is some, so we will use that one اللي هي some values أو existent where the predicate اللي هي bx which denotes x is dishonest and the inverse discourse is some. هنا depends طبعا on more complicated one if you have nested quantifiers. So هذا example هنا for each وهنا for some. هنا for each a some b of x where b a b اللي هي العلاقة نعمة باثنين denotes a plus b equal 0. a plus b equal 0. Now you will substitute that by مثلا numbers. By numbers. فهنا depends on the case. Depends on the case. It's not necessary that any summation will have 0 مثلا, for example. Question so far ولا general هذه تعتبر؟ Okay. Now, sometimes you will be given a predicate مثلا أو you will be given a sentence or statements نحن نقول هنا, then you need to have sort of inferences. Now, there are rules for inferences. هنا they stated 9 common rules اللي addition, conjunctions, simplification, modus ponens, modus tollens, and disjunctive, تمام, syllogism, and hypothetical syllogism, and constructive dilemma, destructive dilemma. Now, let's take some more details and examples. Addition, for example. If B is premise, we can use addition rule to derive B or Q. طبعا ارجعوا الآن للأديشن هتلاقوها عبارة عن ايش؟ اللي هي B over B or Q. So now we need to infer the value if it is related to that one or not. Example will be better هنا. Let be the proposition he studies very hard. He studies very hard. Is true. Therefore, either studies very hard or he is a very bad student. Okay, so now how can you infer that one? Let be he studies very hard. Now, if he studies very hard, then he is what? المفروض he is a good student. Now, how about if he is a very bad student? It means he doesn't study hard. So that will depend on the predicate and depends on the premises of that one. طبعا the same for the and. نفس الidea. He studies very hard. He is the best boy in the class. Therefore, he studies very hard and he is the best boy in the class. Sometimes you might need to have more than one hypothesis. It depends also on the sentences like that one. So this is the way you will deal with the others. Simplification, نفس الفكرة. He studies very hard and he is the best boy in the class. So B and Q اللي هي أول واحدة هذه اللي فوق. Therefore, he studies very hard. If he is what? If he is studying or he is the best student in the class. أعتقد باقي الأمثلة خلاص ما معاها. If you have a password, then you can log into the Facebook. So you have a password, so you can log to the password. So if you don't have, طبعا you cannot. So it depends on also اللي F والدين. F والدين. So if you have a password, then you can infer what is the result. So you can log in. If you don't have, you will not be able to log in. أعتقد الباقي كله بنفس الفكرة. تلاحظوها بنفس الفكرة. If you have a password, then you can log into the Facebook. Okay, now you cannot log on to the Facebook, so you don't have a password. اللي هي النفي هنا تبع نفس اللي شفناه من شوية، ولكن هنا negation تبعها. هنا طبعا you might, as I told you, you have more than one. So مثلا example, if it rains, I shall not go to the school. If I don't go to school, I won't need to do a homework. شوفوا الآن يعني أصبح tool الآن of hypothesis تبع اللي هي it rains. Then based on the result of raining, which is that I will not go to the school, it came the second one اللي هي so if I don't go to the school, so I won't need to do a homework, or I will not take my quiz مثلا, I will not take my exam whatsoever. So therefore, if it rains, I won't need to do a homework. لاحظتوا ربط الآن between the first one اللي هي rains with the sun. هذا اللي ما يطلق عليها اللي هي hypothetical syllogism. طبعا رياضيا is more difficult than that, but as long as the idea is clear that وبنفس الكلام هنا the ice cream is not vanilla flavored. So the ice cream is either vanilla flavored or chocolate. So the ice cream is chocolate. السبب إنه هنا already أنت you said the ice cream is not vanilla. Since it is that or that, and you also negated that one, so it will be for sure the second one. The second. هنا طبعا more complex one. لاحظوها. If it rains, I will take a leave. If it is hot outside, I will go for shower. Either it will rain or it is hot. So I will take a leave. I will go for a shower for both of them. طبعا if both is true. If it is rain and at the same time it is hot. It happens طبعا. It could happen. So now it will, therefore I have to do both. Since it is raining, I will leave. Since it is hot, I will go for a shower. هذه تستخدم by the way دائما في الأبحاث if you need to prove some things that still not clear. Okay, so you came up with an idea with theory مثلا and you will try to approve it. So in order to approve it, you will put all the hypotheses there اللي الفرضيات اللي انت عاملها. So now هنا طبعا just to make it easy, لكن you can convert that to numbers. If all numbers can be divided by 1 and itself, that is the primary number. So any number now, so you have to prove that one. You have to prove that one. So any number now is primary. If I can like 17, like مثلا 23, like مثلا 7. Okay. So is it necessary in odd, since Mr. Shaikhan you said odd numbers? No. 9 is odd number. It is not a primary because I can divide 9 by 1 and itself. But also I can divide by 3. 7, no. Just divide by 1 and 7. So there's no other number that I can divide it. طبعا remaining 0. You can divide it by any number, of course. But what is the remaining? Okay, anyway, that is the idea. It could be more complicated like that one. If it rains, I will take a leave. If it is hot, I will go for shower. Either I will not take or I will not go. اللي هي negation. اللي هي negation. So either it does not rain or not outside, because actually that is my hypothesis there. الايديا كلير. انا you are not required هنا انك you draw مثلا inferences for مثلا difficult equations وكذا, but الايديا انه you can suppose or hypothesize something and you can reach to inference regarding that one. If all grades is greater than A, okay, that what you hypothesized اللي هي افترض هذا الشيء. So now what is the result? Are they all of them A? هنا depends on the case. Depends on the case. Now, if all students, let me give you this example. I need your answer here. If you said, if all students, okay, get greater than or equal 90. So now, what is then? What is then? Yalla, give me your what you have. What is then? If all students get greater than 90, great طبعا.
Then all students will get A.
مثلا, okay, so that is a logic. Logically, based on what you know, that all of them will get A. Now, or they will pass, excellent, okay, or they will pass. Now, sometimes, in some, we were like that, by the way, a few years ago, we were like that. If all students get greater than 90, not sure that they will get A. What they will do, they will start dividing them into groups. So those who got 90 and 91, مثلا, for example, okay, those who got 90 and 90 and 100 عفوا, they will get the A. So only those will get A. ايش كانوا يسموها؟ سكيل اعتقد، سكيل او شيء زي كذا. إذا في طالب قديم حيعرف اللي يتذكرها قبل 3 سنوات 4 سنوات not necessary you get A. فيسي كانوا يعملوا سكيل. خلاص 99 A then لها اسم اعتقد سكيل اذا ماني غلطان, then it will be B plus. So they will decide is it 90 مثلا 7 و 90 A. فبالتالي هنا الانفيرنس wrong. Inference wrong. It has to do some other equation مثلا. It will divide this in group. طبعا will pass excellent because for sure they will pass. Unless what? Unless what? And you said no also. You will be as percentile مثلا. البرسنتايل مر عليكم البرسنتايل. What does it mean percentile؟ مش percentile. طيب ما حد ادخلكم في متاهه لكن generally you might say مثلا 50% of the students got A. Okay. Now you got A, but how much is your grade? Maybe you got A, but you are 90. So how many students greater than you? But not necessary انه خلاص since you got 90 or no, you might take a percentile so that will be يعني judged as a little bit different idea. هذا basically اللي هي الفيرست ستيب. وزي ما قلنا is general. Look at just the idea and how you can build اللي هي truth tables اللي هي propositional والpredicate how you can infer some idea. Next, Turing machines. Anyone get an idea about Turing machines؟ أخذتوها في أي كورس آخر؟ Turing machines مر عليكم؟ ما مر. اوكي since no ما مر. اوكي انا اتوقع الجميع. anyway طبعا التيورينج ماشين هي talks about something generally theory of computation. Theory of computation, how they started and what is the basic idea of computers, of making sort of computations. Okay, so in history there are someone named Turing. Okay, he came up with the idea of a machine. Machine has a tape and then has values and then it will just move a pointer left or right and check cases. هناخذ عليها هنا two examples with more than enough. Turing machine consists of infinite length of tape. هذا التيب zeros or ones or any other value. It could be A's and B's. It could be whatsoever. Okay. Then input is provided as finite sequence of samples. So that tape is infinite, and then I put add inputs as what? Finite sequence of samples. Head, your pointer, reads the input tape. Turing machines starts at start state on reading an input sample. It optionally replaces, if طبعا it needs, replaces it with another sample or ignore, not necessarily replace all the time. Changes its internal state and moves one cell. It could be to the left, it could be to the right. It could be to the left, it could be right. So now we have tape, we have input, read the input and start from starting state نقطة البداية and then start read and compare. Check the case. Should I replace the value or not? If yes, change. If no, just ignore. Change the state. If also needed, then make the move. The move will be either right or left. Let's take an example. That is an example. Okay, Turing machine TM is defined. TM عندك هنا السترينج وعندك التيب وعندك starting value وعندك الانبوت وعندك الهولد. S is a set of states, then we have a set of tape samples, then we have the starting state or the start state, then we have a set of halting states. Which one will make the halt? Then finally is the transition function. لاحظوا هنا عندي left or right based on criteria. Based on criteria. Turing machine U plus 1 given string of ones on a table. We have ones followed by infinite number of zeros. When I say infinite, it will end somewhere, okay, but we don't know how many zeros are there. Add one more one at the end of the string. So now I need to check. That is 1, that is 1, that is 1, that is 1, that is 0, 0. So it means I finished the ones. Now I'm working on the zeros. Once I reach the end, it should add one more one at the end of the string. See how does it work? See how does it work? S0, 1. So S0 is 1. What will happen? It will remain 0. 1 is still 1. Replace by 1. Leave it 1. Keep it 1. And go to the right. Go to the right. So the result is that one. I moved to the right. I kept it 1. Check the second one, S0. So I am still here. S01. So I will not go to that one because S0 is still 1 of 1. Do the same. Keep it 1. Go to the next, right. S0 is 1. I will remain here. S01R. So it will go to the next. So it will keep doing that as long as you have 1. It will remain right here. It will keep going right, 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 right. Okay? Now, see what will happen here. The last one, you have S00. Now, that one is S01, so it will not work. It has to go to the 1. It has to go to that 1. So that will make H halt. Adding 1 and stop. No more running. So now instead of having 4 ones, I will have 5 ones. Halt, exit. Now that is very simple example. Now what Turing did actually, he started exploring some difficult concepts. مثلا if condition, for loop, searching, sorting could be, okay, depends on the case. لكن احنا هنا we will not go that far because as I told you, أنا myself, I took a course in my master degree, just theory of computation. Talks about Turing machine. Mainly, طبعا, course having so many things, but the main part is a Turing machine. لو تروح تفتحوا الجوجل, just write Turing machine. You will be amazed. يعني so many things talk about that. Another one, exercise. You have states S0, S0, 1, 1. But that one is if it is B. That one if it is A. So that's why you have 2 zeros. Depends on in which value I am working right now. In which value I am working now. The same S1. S1, S1 depends on in which value. Now, what is the difference between two? Right here. Right here. طبعا it happens here, you know, all of them moving to the right, even the previous example. لكن sometimes you will find no, move right, move left. ممكن, it happens. Now let's see that one. How does it work? But what is that required هنا? First of all, input is A, B, which is that one. What is the output for this input? So now, just follow that one by one until you reach to the end. The end will show you the output. I did that for you. You will not find that one in your slide, but I actually save your time. See now, S0A. That is S0A. So will remain A, replace A, go to the right. So now I will go to the right. طبعا why is it هنا S1? Because S0A, it should change to S1. I have to change it to S1. Now, next time, S1A. So now I will not go to the 0, I will not go to 0, I have to go to 1. Which one of them? Is it this one or that one? Since I have S1A, so I have to go to that one. When I go to that one, it will change to S0. Ooh. Replace it by A. Go to the right. So now, if you just keep going, you will find that S0A, that is AA, then S1 still AA, because here's A, here's A. Now, look at that one. That will make the change. S1B. Now I have to go to that one, because it's S1B. Now, S1B, first of all, it will halt. تتوقف هنا خلاص. Replace by B. Stop. حطوها هنا. فبالتالي ايش اللي حصل هنا؟ معايا؟ So it will hold, وبالتالي that is the output. كأنه في بس في شيء هنا خطأ أو شيء، أو لا نتهيألي كأنه في شيء صح؟
والمفروض استبدل بالبي، بس في ايه بعدها.
ايوه المفروض انه يستبدلها بالبي. انت صح، انا شيء شكيت فيها. يعني S1B وهي هنا S1B حيتوقف، متفقين عليها خلاص. لا هذه المفروض زيرو باي ذا واي، هذه زيرو، هذه المفروض انا حوريكم اياها الان. هذه زيرو، لاحظوا هنا S0B. So S0B. So B will be replaced by A and stop. أنا هقول لك ليش زيرو الآن، هوريك الآن ليش زيرو. Okay. So now لاحظوا معي هنا. The first one is 0A. So it should change to S1. Second one S1A. صح؟ S1A حيجي هنا. S1A should return it back to 0. So now it is returned back to 0. S0A حتيجي هنا. It should be returned to 1. So now it is returned to 1. S1A, it should be returned to 0. So S0B, عيدوها انتوا الآن. S0B حتروح تغيرها إلى A ودد الB ل A. So it replaced that B by A. So left only one B. Should I continue? No. Because now I have to stop. I have to stop. So it just replaced the last B, or the first B. Wait, change it to A, then stop. So it's supposed to be 0. That is 0. questions. وطبعا واضحه، لانه لو قلت له انا S1B حتفضل B. واضحة، لأنه هنا S1A زي هذه، زي S1A. S1A changed what to 0، فبالتالي لازم تتغير إلى 0. Any questions؟ الفكرة واضحة. تيورينج هو مجرد، الآن نشوف التيورينج. Any mathematical problem solving that can be described by mechanical procedure زي algorithm مثلا can be modeled by Turing machine. أي if, loop, instructions, plus, multiply، أي شيء، any operator. Okay, all computers today perform only mechanical problem solving. They are no more expressive than Turing machine. The idea is still the same. The idea still the same. The halting problem. Given a program and an input to the program, determine if the given program will eventually stop with this particular input. So with that particular input اللي هي stop، إما يكون S0B so I will stop، or S1A لا عفوا S1B also it will stop. Other than that it will keep going right. Now depends on how many A's are there. How many days are there. هذه اللي هي الفكرة. If the program doesn't stop, usually we say that is infinite. So it will keep going since there is no state cover that one. Where to stop. So that's why in our loops, if you put the loop in a way that will never reach to that value, we say infinite loop. Will never be. So that states it's not covered, so it will just keep forever, keep running forever. With the problem أكيد إنها حتكون unsolvable. Turing's thesis is not theorem. There's no proof of the thesis. Okay, the theorem may be refuted by showing at least one task is performed by digital computer which cannot be performed by Turing machine, which is still unknown. Many contentions have been made to this end. However, till date, طبعا اتكلم عن السلايدز كلها سنتين 3 4. Okay, there have not been any conclusive evidence to refute Turing thesis. يعني بمعنى still working until someone prove that no, we have a case that cannot be solved by Turing thesis. Turing machines are minimal extensions over PDAs which provide greater expressiveness. TM or Turing machine are at level that much very important here. Turing machine at a level that is much below assembly language. Now, what are the levels of languages? Generally, we have 3 levels. Generally, we have اللي هي الماشين language والassembly language والhigh level language. So, high level that any language that you know, any language, let's say Python or Java. Now, below it is assembly language. That one is much below also the assembly language. So, now, can I make a program using Turing machine that will calculate the sum of numbers? Yes, you can. Yes, you can. But you might spend 2 or 3 weeks to do that. And in order to have a table, in order to have an input, in order to check the values and add it to the فكرتي. So it's not easy. But at the end, when you write a program in high-level language, what happens? Once you compile it, it will go back to the machine language. It will go back to the machine language. So that's why now it can be done by Turing machine. It's below the assembly language. أحد برمج في assembly قبل كده؟ أحد اطلع على assembly language؟ أي assembly language؟
assembly مثل ماري سيميوليتر.
يعني هي فكرتها إنه مثلا عندك أوامر زي كذا، تقول مثلا يعني إيش حصل؟ مثلا تقول له move، هذا أمر عندك، أوكي؟ ممكن تقول له add. هذه هم when they came up with the assembly language, it was a great step. إنه the previous one كان zeros and ones. The previous one كانت zeros اللي هي machine language. So to program مثلا a code that will add two numbers, you might spend 2-3 weeks. In assembly language, you can do it in less than that. مثلا يمكن in 1 day or less than 1 day if you are an expert. Now you can do it in 1 or 2 minutes using the high level language. أتوقع أخذتوها في ال M105. مرت عليكم في ال M105؟
بتذكر مريت بالتي ام 103 اتوقع. تي ام 103.
يس انت صح. المري اظن اسمه هذا اللغه اللي نزلتوها مري.
أيوة.
او حاجه زي كذا.
ماري سيميوليتر
او ماري او حاجه زي كذا. الا انا ما درست الماده هذه، بس يعني عندي فكره عن الموضوع. شوف اذا لقيت بس فيري كويكلي ما اطول عليك الموضوع. للاسف ما في ام 105. لو في ام 105 كان وريتكم اياها unfortunately. خلاص ما هي موجوده، فبالتالي تسامحوني. اذا موجوده الام 105 if you check slides you will find that one. في واحده من السلايدز موجوده. it will show you that we have اللي هي 3 types اللي هي الماشين والاسمبلي واللانجوج. طبعا if you ask now anyone which one is better to program, is it high level or assembly or language? يمكن all of us, one of you, okay, I will say high level. But actually, if you program using a machine language, that is much controllable and powerful. فهمت فكرتي الآن؟ It will be much. طبعا it's impossible. أنا يعني you cannot do that because it's not easy task. It's not easy task. واللي جرب ال 103 يمكن يأكد على كلامي. Computability and limits of computation are the last for the whole course inshallah. Limits on arithmetic, limits on components, limits on communications. What are the limits we have in general? Okay, in general, limits on arithmetic, there are limitations imposed by hardware on representations of both integer numbers and real numbers. What is the maximum number of significant digits that can be represented is limited to certain value. Significant digits, those digits that begin with the first non-zero digit on the left and end with the last non-zero. لأنه بعد كده any zeros to the left is يعني ما له قيمة, has no value. So now, what is the maximum number? It depends طبعا, depends. Limits on components. Although most errors are caused by software, hardware components do also fail. Error detection codes, techniques to determine if an error has occurred during transmission of data, for example, and then alert system. If you transfer data, so what sort of error? Even by the way, حتى في types, numbers هنا. يعني if you declare integer, so what is the maximum of integer that is accepted by the software? يقول لك في الجافا مثلا 32700 حاجه زي كده تقريبا. تتذكروا الرقم هذا؟ if you declare an integer number. طيب if I declare it as byte, what is the maximum number? byte 128 ولا 255؟ طبعا لا الان هنا
28.
ايوه الله يبارك فيك. تمام. ارجع حتى احيانا المور دقه يقول لك 127 اذا تتذكر، ما ادري ما تتذكر 127 ولا 128؟
127 عشان الصفر بنحسب مع البوزيتيف.
يقول لك so that's هنا لهذا يقول لك هنا almost most errors are caused by software but sometimes also the hardware will take part of the errors. انا ما اختبرك يعني، لكن الفكره انت صح. اوكي so error correction code طبعا error detecting cause that detect an error has occurred and try to determine the correct value. هذه انا متاكد انها مرت عليكم في التي 111 فاكرينها؟ يتكلم عن الليميتيشن هنا طبعا، وهناك يتكلم عن الديتكتنج الايرورز. مين اخذ تي 111 الترم الماضي؟ الترم الماضي
أنا
فاكر هذه ديتكشن الايرورز مرت عليك؟
أتوقع يمكن المحاضرة قبل الأخيرة يمكن.
اعتقد كذا، انا مع اني ادرس ماده الترم هذا بس والله ما احفظ فين كانت في اي سلايد. بس عشان تكون الصوره واضحه. يس شايفين هنا الان error correction، هي طبعا detection الاول بعدين correction. ايش الايديا هنا؟ الايديا يقول لك if I مثلا use ال ARQ protocol the sender will wait for acknowledgement frame from the receiver. If it is not received then frame is just retransmitted. هذا sort of solutions. عندنا احنا ال ARQ، عندنا ال FES، اشهرها الباريتي شيكس، تاخذوها فور شور في بعض المواد، يمكن اخذتوها اوريدي في 215 او شيء زي كذا. تمام. فاذا هنا الايرور كوركشن، الايرور كوركشن هنا عندي if I use the FEC let's say I need to send that stream of binary. Now how can I be sure that it is received correct by the destination? So ببساطة كده okay you will repeat ال1 3 times, you will repeat ال0 3 times, you will repeat ال0 3 times and send that one. Now if received as is the destination طبعا كله في الأخير software hardware, the human being will not intervene here, never. Okay, so now that will check 3 ones, yes, so it's only one. Come back to the original one. So now that one 3 zeros, we discover that it is received as 100. Now there is an error because it has to be the same, either 111 or 000. In this case, what do you expect the error will be corrected? How it will be corrected?
It will be zero.
Zero. ليش change zero؟ لأنه it will take the best of 3 algorithm. Over there it says since we have 2 zeros and 1 1, so we'll take the best. The best enough, as you said, it will be converted to 0. طبعا هذا يعني it is viable to errors also. يمكن by mistake it happens that 2 ones and 1 0. So now it will go back to what 1 1 1, but actually it is 0 0 0. 0 0. Okay, هذا part. Number 2 طبعا عندنا الباريت شيك، ما هشرح لكم اياها بس هي هذه جدا جدا very famous في الكوميونيكيشن اللي هي error correction. Very famous. It will look at even or odd. Is it even or odd? So now we will check that the code is using even parity. So now how many ones are there? Even? Yes, valid. How many ones are there? Even? No. So that's invalid. It has to be fixed. How it will be fixed? That's a long story. اللي أخذ 111 اكيد اتذكر هذا الشيء. So I'm just show you what happens there. So there is an error detecting and an error correcting code. Commercial software contains errors. Software testing can demonstrate the presence of bugs. معنى هذا المصطلح that we use it all the time, bugs. So but cannot demonstrate their absence. It can detect the bugs, but if it is absence, it cannot. As we find problems and fix them, we raise our confidence that the software perform as it should. طبعا all of that depending on the testing. How about if I tested the software but I did not test certain part, or I thought now I tested that one but I said it's work, but when I use it with some other functions مثلا it will not work. For example, that's why اللي اخذتوا التكستينج في 354 حتلاقوا انه في تيستينج اللي هي individual functions. في testings you will take it as a whole. فانت you have 5 functions. If you test the functions individually, it's working fine. But you have to check if you use them together. يعني مثلا I have a function that will sum numbers. Another function divide numbers. So now I need to get the average. So I will use the first one just to make the sum. The second one divided by numbers of numbers. Now it has, or you have to use both functions. طبعا some of the testers يعني to save their time they said I checked both of them and they are working fine. As individually, yes, but together, no. But we can never guarantee that all bugs have been removed. It will take some time, long time. You discover all the bugs. Thank you very much. That's it for today. That's it for the whole semester. Now it's up to you, and I'll be available, inshallah, Tuesday. But there is nothing to explain unless you need to ask about certain things. Any questions, any comments, anything that you need to know? Nothing. نقول لكم شكرا وخواتيم مباركة يعني.
Thank you Mr. Shaikhan.
يلا على كل حال